I'm going to do a brief overview of what a relation and a function is. And this is in your packet, so please write down anything that I have on here. It's not a lot. So first off, what is a relation? So a relation is just a set of ordered pairs, okay? A relation can be represented by a set of ordered pairs, a table, a graph, or something called a mapping diagram. And we'll go through each of those four in a minute, okay? The set of the first numbers of the ordered pairs is the inputs, and the set of the second numbers of the ordered pairs is the outputs. Okay, so putting in the input, getting out the output. Okay, so a relation isn't anything fancy. It's really just like a relationship between these numbers and these numbers. Okay, so those four ways of representing the relation, once again, down here on the bottom, we have a set of ordered pairs. Now this one looks a little bit weird because they kind of broke it down onto 3 lines for sake of space. Really, you'll probably see them like in a string going across. But notice that we do have this set of braces on the outside. We're going to be using those a lot in this section because that shows a set. So whenever we put things in a set, we use those braces around the outside, whether it's a set of ordered pairs or just a set of numbers. Okay, we want to make sure we're using those braces. Okay, so that's the first way of representing a relation, our ordered pairs. Okay, the second way is our input-output table. Okay, you can have it vertically or horizontally. Okay, but either way, the x's will always be first and the y's will be second. And those x's are the inputs and those y's are the outputs. Okay. With ordered pairs, we can graph ordered pairs. So the third way is on a coordinate plane. Okay, so I actually believe these are the same points over and over again here. So you'll see 3, 2, and you'll have 5, -1. So they took all these ordered pairs, as well as the same ordered pairs in the table, and they put it on a coordinate plane for us. Okay, that's another way of showing a relation. And then the last way, which is the new way that you guys probably haven't been exposed to, is this mapping diagram. And mapping diagrams are nice because you can kind of see a nice flow of what's going on between the inputs and the outputs. Okay, so you're just going to follow the arrows. So you can see that 3 in this case is paired with 2. Okay, 5 is paired with -1. -4 is paired with 3. I'm just following the arrows across. So this would be like 3, 2, and 5, -1, and -4, 3, which you can see were our first 3 ordered pairs up there. But then we get to 2, and 2 is paired with 0, and 2 is also paired with 5. So if there's something where an input has 2 different outputs, you're going to see 2 different arrows coming from the number going to those 2 different outputs. Okay, and then the last one was -3 is paired with 2. Okay, so the mapping diagram breaks it down into the inputs and the outputs and then draws arrows from each input to its output or outputs if it has more than one. Okay, so that's relation. Relation's just a pairing of numbers. Okay, nothing special. What we really care about is what is a function. Okay, this is what our topic is about. Okay, we're talking about linear functions. Okay, and the function definition is one of those definitions that you really got to know. Okay, we're going to say it over and over until you're sick of it, to be honest. Okay, but a function is a relation where every input has exactly one output. Okay, so if I go back to our one that we did before, this one actually is not a function, because if I go back to that mapping diagram, I'm going to get rid of all my scribble over here. If I go back to that mapping diagram, we talked about how 2 went with 0, but 2 also went with 5. 2, the input of 2 had 2 different outputs. So that is not a function. Everything else was good. Okay, we had 3 paired with 2 and 5 paired with -1, -4 paired with 3, -3 paired with -1. Each of those only went to one output. So if it was only those 4, we would be okay. But because of that that +2 going to 2 different ones, this meant it was not a function anymore. So each input can only have one output. So one thing that a lot of people look for, and I will say it usually works, is that you're looking to see if the x's repeat or not. If the x's repeat, that usually means that it's going to be going to two different outputs, which we can't have in a function. It can only go to one. I will say be careful and make sure that it's not the same ordered pair just listed two times. Okay, so if that's the case, then it's not going to two different outputs. It's just there twice. Okay, but usually the x's can't repeat because that means that the x is going to be paired with more than one number. When we have a graph, there's something specific we can use for graphs, and it's called the vertical line test. So what happens if we have, I'm going to go back to this one again. Okay, when we took these ordered pairs and we put it on the coordinate plane, when we had that 2, 0 and that 2, 5, when we graph them, if we look at that section of the graph right there and we draw a vertical line through it, it hits the graph twice. Okay, so if it hits the graph twice, that means that there was an input, in this case 2, that had those two different outputs. So when we use this vertical line test for drawing these like imaginary vertical lines all throughout the graph, whether it's points or a curve or a line, okay, we're drawing these vertical lines. If it hits it once in every single spot, that means it's good. It passes the vertical line test. It's a function. If it hits it more than once on the way down anywhere in the graph, then that means it fails the vertical line test and it wouldn't be a function. Okay, so let's go through some examples and non-examples here. Okay, nothing for you to really do here. Okay, just pay attention. So the first one, we have 1 paired with 2, 2 paired with 4, 3 paired with 6. We can clearly see that each of the x's is only paired with one y. This is a function. Each input has exactly one output. Okay, we have our string of ordered pairs right here. 1 is paired with 1, 2 with 2, 3 with 5, 4 with 10, and 5 with 15. Okay, I think the ordered pairs are probably the hardest ones to see because they're written out horizontally. So you have to really be careful and make sure no x is paired with more than one y. But hopefully we can see here that each x is only paired with one y value. So this one is a function. Here we have a graph. So with our graph, we can use the vertical line test. Okay, I'm going to actually draw it out on the screen so you can see what I'm doing, but you probably don't necessarily have to actually draw it out. But I'm going to start kind of drawing some vertical lines and seeing, does it hit my graph only once? So if I draw a vertical line here, hits it only once, hits it only once. No matter where I draw that vertical line in here, it's going to hit that line only one time. So that one is a function. Okay, it passes the vertical line test. I'm actually going to add one more example in here because I think it's an important one. Okay, so I'll do a very, very tiny one. Let's do a mapping diagram. So we'll do 1, 2, and 3. And the only output's going to be 4. Okay, so I'll have 1 be paired with 4, and 2 be paired with 4, and 3 paired with 4. And a lot of people think this one's not a function because they're like, oh, they all have 4 as an output. It is totally okay for functions to share, for inputs to share an output. Okay, what you're really checking for is to make sure each input is only matched with one output. So 1 is only paired with 4. Okay, 2 is also only paired with 4, and 3 is only paired with 4. So this one looks a little crazy, but this one is a function. Each input only has one output. Okay, they all have the same output. That's okay. Okay, so those were all examples of functions. We were either looking to see, does each input have exactly one output? Or if it's a graph, does it pass that vertical line test? Is it only going to hit the graph one time if you draw those vertical lines in? Okay, and then our non-examples, okay, I see a graph, first one, so I'm like, ooh, vertical line test. So I'm going to take my pink pen and I'm going to draw my vertical line. And as I go down, I'm going to hit my graph 1 time and 2 times. Okay, and in most spots in the graph, that's going to happen. Okay, the only time it wouldn't happen is right here. But even if it only happens once, okay, I hit the graph once, twice, This fails the vertical line test. I can see that this input of 1 would have 2 different outputs. Okay, this fails the vertical line test. This one is not a function, hence why it's in our non-example section. Okay, not a function. I'm going to do that. So non-examples mean not a function. Okay. For the next one, we have a set of, we have a table of values, and I can see a couple things happening here. I see 4 is paired with -2, and 4 is also paired with a +2. I also have 1 with a -1 and 1 with a +1. So there's actually 2 cases where an input has 2 different values. 4 is paired with -2 and +2, and 1 is paired with -1 and +1. Okay, each input can only have one output. Okay, so this one is not a function. Okay, and then in our last one, in our mapping diagram here, I see that first one right away, 1 is paired with 3 and 1 is paired with 4. So that would not be a function because 1 has 2 different outputs.